Let's start with what is water pollution. Water pollution is defined as the degradation of water quality. Water quality is determined by its effects on public health, how far away it is from normal concentrations, the expected end use, and the impacts on the ecosystem. Water pollution can be defined as unclean or diseased drinking water. Water pollutants include heavy metals, sediment, certain radioactive isotopes, heat fecal coliform bacteria, phosphorus, nitrogen, sodium, and other useful and sometimes even necessary elements, as well as certain pathogenic bacteria and viruses. Fracking has been found to cause water pollution in several states. In Wyoming, fracking caused the Wind River Basin's groundwater source to become polluted with toxic chemicals. Most water pollution is a result of runoff and leaks into surface water or groundwater. Pollutants are also transported by air and deposited in bodies of water. Point sources are distinct and confined, such as pipes from industrial and municipal sites that empty into streams or rivers. Non-point sources are those that come from a large area, such as parking lots, agricultural land runoff, or sediments. Think of it like this. If you can't trace it back to one specific place or thing, we can consider it a non-point source. Non-point sources of pollution have been identified by the EPA to be the primary reason for continued water pollution problems. The EPA has reported that 1/3 of the nation's drinking water does not meet quality standards. Now we ask, what is runoff? Runoff is water that runs over the surface of land and collects all of the pollutants that were deposited on that surface. Pollutants in runoff can include nitrogen, phosphorus, fertilizers, pesticides, silt, pathogens, ammonia, and many others. Runoff is a type of non-point source pollution because its source cannot be pinpointed back to a single place. It is difficult to monitor disease-carrying organisms directly. We use the count of fecal coliform bacteria as a standard measure and indicator of disease potential. The presence of fecal coliform bacteria in water indicates that fecal material from mammals or birds is present, so organisms that cause waterborne diseases may be present as well. The growth of the fecal coliform bacteria will cause an increase in the biological oxygen demand. Two important nutrients that cause water pollution problems are phosphorus and nitrogen, and both are released from sources related to land use. Agriculture causes contamination when phosphorus and nitrogen are added to water. The amount of oxygen required for biogeochemical decomposition processes is called the biological oxygen demand, also known as BOD. BOD is commonly used in water quality management and testing. Dead organic matter, which produces BOD, enters streams and rivers from natural sources such as dead leaves from a forest, as well as from agricultural runoff and urban sewage. Okay, let's move on to eutrophication. Eutrophication is the process that occurs when excess nitrogen and phosphorus cause algae and other organisms to use up all accessible oxygen. This causes other living organisms that need oxygen to die. Cultural eutrophication is an anthropogenic addition of nutrients to a body of water. Examples of cultural eutrophication are runoff from animal agriculture, sewage, and aquaculture. Eutrophication can cause algal blooms, lower levels of photosynthesis in the water column, increased levels of nutrient concentrations, and a decrease in dissolved oxygen levels. Dead zones occur due to hypoxia in areas where oxygen is depleted due to excess nutrients. But what is the solution to cultural eutrophication? In order to prevent artificial eutrophication, it must be ensured that high concentrations of nutrients from human sources do not enter bodies of water. This can be accomplished by using phosphate-free detergents, controlling nitrogen-rich runoff from agriculture and urban lands, disposing of treated wastewater, and using more advanced water treatment methods, such as special filters and chemical treatments. Now we must ask the question, what is sediment pollution? By weight, sediment pollution is the most abundant water pollutant. Sediment pollution can be minimized by trapping eroded sediment at construction sites, exposing only minimal amounts of land at a time, considering the natural contours of the land during construction, and providing protection of exposed soil during construction. Let's move on to wetlands. Wetlands are natural functioning forms of water treatment and purifiers. They perform secondary and tertiary treatment. The principal advantage of using wetlands for wastewater treatment is that a natural ecosystem replaces industrial methods for secondary and advanced treatment. As shown in the diagram, wetlands work by using bacteria to break down contaminants from groundwater. The water is then stored in a saturated peat and slowly released into a stream. Water filtered of contaminants provides critical wildlife habitats and a cleaner water outflow. Now that we know what wetlands are, let's learn how we classify them. Wetlands are classified according to their hydrology, soil type, and species composition. Hydrology will usually have standing water. Soil type is usually rich on organic matter. Species composition are usually riparian in nature. Riparian vegetation is vegetation that is found near streams. Alright, now it's time to learn how to clean surface water pollution. One method is nanotechnology. It uses extremely minute particles to help treat wastewater. A second is urban runoff naturalization, an emerging bioengineering technology used to treat urban runoff before it reaches streams, lakes, or the ocean. But what about groundwater pollution? Sources of groundwater pollution include landfills, subsurface gasoline tanks, oil spills, and saltwater intrusions. Soil, as a hazardous pollutant of groundwater, is removed and disposed of through the very expensive process of vapor extraction. Treatment may also use microorganisms that consume gasoline. This is known as bioremediation and is much less expensive than the other options. Some pollutants, such as gasoline, are lighter than water, so float on the groundwater, and other pollutants have multiple phases, being liquid, vapor, and dissolved. Dissolved phases chemically combine with groundwater. Let's move on to saltwater intrusion. First of all, what is saltwater intrusion? Groundwater in coastal areas can have saltwater introduced into the aquifer. This usually occurs when local water users remove more groundwater than is naturally replaced. Next, how are diseases transmitted? Diseases can be easily transmitted in water. In water, cholera is tested by looking at coliform bacteria content, the most important concern for water treatment. Now, what is a septic tank? Septic tanks treat wastewater in rural residences. A sewer line from the house leads to the septic tank where liquids and solids are separated. The system stores organic matter, allowing the clarified liquid to drain from a piping system. The treated sewage seeps into the surrounding soil where it is further treated by the natural processes of oxidation and filtering. The water should be safe by the time it reaches a freshwater supply. Wastewater treatment costs about $20 billion a year in the U.S. Treatment is categorized into primary treatment, secondary treatment, and advanced wastewater treatment. During primary treatment, soil debris are removed by screens and meshing. Different processes are used to filter and allow sediments to settle. A flocking agent can be used to force chemicals to precipitate, clump, and settle out. Secondary treatment involves organic matter being consumed by bacteria that need oxygen to assist in removing the organic waste. In tertiary treatment, carbon filters, chlorinization, UV, or ozone can be used to sterilize and kill pathogenic organisms. Wastewater treatment does not produce drinkable water because it cannot remove nitrogen, phosphorus, or pharmaceutical drugs. Bioremediation is the use of bacteria to clean up pollutants such as oil spills. In 2010, 3.19 million barrels of oil were spilled into the Gulf of Mexico. This catastrophe, known as the Deepwater Horizon oil spill, was cleaned using methods of bioremediation, known as bioaugmentation and biostimulation. Wastewater is being supplied successfully to natural and constructed wetlands at a variety of locations. In Las Vegas, new resorts are required to treat wastewater and reuse it for fountains, rivers, canals, and lakes. This is an example of a policy instrument being used to protect the environment. Next, drinking water treatment methods includes absorption, disinfection, filtration, flocculation, and ion exchange. Absorption is a process in which contaminants stick to the surface of granular or powdered activated charcoal. In disinfection, chlorine, chloramines, chlorine dioxide, ozone, and UV radiation are used to treat water. Filtration involves removing clay, silts, natural organic water, and precipitants from the treatment process. Filtration clarifies water and enhances the effectiveness of disinfection. Flocculation is a process that combines small particles into larger particles that then settle out of the water as sediment. Alum, iron salts, or synthetic organic polymers are generally used to promote coagulation. Lastly, ion exchange removes organic constituents. It can be used to remove arsenic, chlorium, excess fluoride, nitrates, radium, and uranium. There are many methods of cleaning groundwater. Enhanced bioremediation is an enhancement of the natural rate of bioremediation induced by adding oxygen and nutrients into groundwater. A fluid vapor extraction is a vacuum system that is applied to low permeable soil to remove liquids and gases. Granulated activated carbon involves groundwater being pumped through a series of columns containing activated charcoal. Hot water flushing is a process of steam or hot water being forced into an aquifer to vaporize volatile contaminants. The water is then treated with fluid vapor extraction. In-well air stripping involves air being injected into wells in which air picks up various contaminants. Then, ion exchange involves exchanging one ion for another. Next, bioremediation uses plants to remove contamination. And finally, UV oxidation uses ultraviolet light, ozone, or hydrogen peroxide to destroy microbiological contaminants. The Clean Water Act of 1972 established the basic structure for regulating the discharge of pollutants into waters. It gave the EPA the authority to implement pollution control programs and set requirements for the industry. The Safe Drinking Water Act of 1974 established standards for safe drinking water. The Ocean Dumping Ban Act of 1988 made it unlawful for any person to dump or transport for the purpose of dumping sewage into the ocean. The Ocean Spill Prevention and Liability Act of 1990 strengthened the EPA's ability to prevent and respond to catastrophic oil spills. Together, all of these acts are examples of policy instruments being used to protect water.